6.6 Part 2, Composition of Functions. Let f of x equal x minus 5 and g of x equal x squared. What is g of f of x? Okay, so another way to write this would be g of f of x. So it's like we want to plug in, or g of f of negative 3. We want to plug in negative 3 to the inside there, to the f function, and then we're going to take that answer and plug it into the g function. Okay? So let's go ahead and we'll just kind of color code this. So we'll go g of f of negative 3. So we're going to figure out what f of negative 3 is first, and then take that answer and plug it into the g equation. So what does f of negative 3 mean? That means instead of putting x in your equation, you're going to put a negative 3. So it's saying, using the function named f, what would you get when you put negative 3 in for x? Okay, what would that y value be? So that's going to be negative 3 minus 5. So f of negative 3 equals negative 8. So now we take that answer and we put it into our g equation. Okay, so we're plugging one equation into the other. So now it becomes g of negative 8. So if I take my g equation, which was g of x, instead of x, I'm going to put a negative 8 in there. So g of negative 8 equals negative 8 squared, okay, which is 64. So that's saying on the g function, when your x is negative 8, then your y is 64. Okay, now notice this was g of f of negative 3. What would happen if we did f of g of negative 3? So this is going to be the other way around, and usually it'll give you a different answer. So f of g of negative 3. Okay, so we're going to use the f function and then put that g answer into it. So what is g of negative 3? What this means is, again, when the x is negative 3 in the g equation, what do you get? So we're going to go negative 3 squared. So g of negative 3 equals 9. So now instead of f of g of negative 3, I want to actually fill that 9 in there. Okay, so what's f of 9? I'll go back to my f equation, which was x minus 5. 9 minus 5. So that means when x is 9 in the f equation, your answer would be 4. All right, let's try some other ones. These ones are in a little bit different notation, and we're not going to find an answer as a number. We just want to simply plug one equation into the other. Okay, so we want to find f of g of x. So it's like we're plugging in the g equation into the f equation. So all of this will be going in for x. So we're finding f of x plus 3. So instead of filling in a number in the f equation, it's going to be filling in this expression. So what squared minus 9? So that's the f equation. And then I'm going to fill in x plus 3. From there, you can just continue to evaluate it. So how would I do x plus 3 squared? Well, that would be x plus 3 times x plus 3, and then minus 9. So first, outside and inside combined together is 6x, but I'll write that out. Outside, inside, and last. And finally, don't forget about that minus 9 that was on the edge. Okay, so the 9s will cancel. So f of x plus 3, so when I plug in f of g of x, when I plug in the g of x equation to the f of x equation, I get x squared plus 6x. Okay, how about g of f of x? So same equations, just the other way around. This time I want to plug in the f equation to the g equation. So I'm going to go g of f of x. And again, this is just a different notation, g of f of x. You'll see it written a couple different ways. So you'll see it written like g of f of x, or g of f of x, or g of f of x. Okay, all those ways mean the same thing, just different notations to write the same thing. All right, so our g equation is our big equation. So x plus 3, and then we're putting in the f equation to it. And then it'll just be x squared minus 6. All right, let's try the next one. So the difference to this one is you have a fraction here, but otherwise we're doing it the same way. So f of g of x, f of g of x. So the f equation is our big equation, and again we're plugging in the g of x. Okay, so how would I simplify this? So if you want to combine these, you want to get a common denominator. So we can put the 5 over 1, and our common denominator would be 3. So times 3 and times 3. All right, so this simplifies to be, if we put these, so how do I combine fractions? Think about if you have like 1/3 minus 2/3. Well, as long as you have that common denominator, you can subtract the numerators, right? So we can rewrite this as all over 3. So we can go x plus 3 minus 5 all over 3. So then that would just be, oh, minus 15, there we go. Because 5 times 3 was 15. So x minus 12 all over 3. When we get into the next section, we'll want to graph these out. So if I wanted to graph this equation, remember that you can rewrite it 1/3 x and then 12 over 3 minus 4. So if I wanted to graph this, then we can come down 4, up 1 over 3. So we don't need to do that today, but for section 6.7, we'll need to be able to graph linear equations. Okay? All right, let's go to the next one. And actually, I'm going to put the problem back up here. I want you guys to try g of f of x. So go ahead and pause your screen and try what g of f of x is. All right, so we're going to plug in our x minus 5 to the g of x equation. So we should get x minus 5 plus 3 all over 3. And then if you simplify, so again, you can just leave your answer as this. Next section, we'll move on to graphing, so we'll want to more put our answer like that. All right, so go ahead and get started with 6.6 part 2.